Several asteroids have been identified as potentially hazardous, meaning they have orbits that could bring them close to Earth in the future. One of the asteroid is 1950 Da. Asteroid 1950 Da is one of the most intriguing and well-studied asteroids due to its potential to impact Earth in the distant future. It has captured the attention of astronomers and scientists due to its size, composition, and the relatively high probability of collision with Earth compared to other known asteroids. 1950 Da was first discovered on February 23, 1950, by astronomer Carl A. Wirtanen at Lick Observatory in California. After its discovery, the asteroid was observed for a total of 17 days before it moved out of the observable range of telescopes. It wasn't until 51 years later, on December 31, 2000, that it was rediscovered by astronomers at the Lowell Observatory Near-Earth Object Search (LONEOS) program. The asteroid was given the provisional designation 1950 Da after its rediscovery matched with the lost asteroid from 1950. Semi-major axis, 1.699 astronomical units. Eccentricity, 0.5083. Orbital period, 2.21 years. Inclination, 12.2 degrees. 1950 Da follows an elliptical orbit around the Sun, with an orbit that takes it from a minimum distance of 0.86 astronomical units, closer to the Sun than Earth, to a maximum distance of 2.54 astronomical units, beyond Mars. The asteroid's highly elliptical orbit and its interaction with Earth's gravity are key factors in determining its potential future trajectory. Size: approximately 1.1 kilometers, 0.68 miles, in diameter. Mass: estimated to be around 4 × 10⁻12 kilogram. Density: about 3.5 grams per cc, suggesting it is composed of dense rock or metal. Rotation period: 2.1216 hours. 1950 Da is a relatively large near-Earth asteroid, NEA, with a diameter of over a kilometer. Its size is significant because it falls into the category of potentially hazardous asteroids, PHAs, which are large enough to cause widespread destruction if they were to collide with Earth. One of the most interesting features of 1950 Da is its rapid rotation. The asteroid has a rotation period of just over 2 hours, which is close to the theoretical limit for how fast a rubble pile asteroid, a loosely bound collection of rocks and debris, can spin without breaking apart. This rapid rotation suggests that 1950 Da may have cohesive forces, such as van der Waals forces, holding it together, which is unusual for asteroids of its size. The composition of 1950 Da is not definitively known, but its density suggests that it may be composed primarily of nickel-iron or a mixture of silicate rock and metal. The asteroid's surface is likely to be irregular, with a mixture of craters and boulders, much like other similar-sized asteroids observed up close by spacecraft. Spectral analysis places 1950 Da in the X-type category, which typically includes asteroids with metallic compositions. However, X-type asteroids can also be composed of enstatite chondrite, a type of stony meteorite that is rare on Earth. The most notable aspect of 1950 Da is its potential to impact Earth on March 16, 2880. The asteroid has been calculated to have a relatively high probability of collision with Earth for an object of its size. Current estimates put the probability of impact at around 1 in 8,300, or approximately 0.012%. While this may seem like a small chance, it is considered significant by the standards of planetary defense. If 1950 Da were to collide with Earth, the impact would release an immense amount of energy, equivalent to approximately 44,800 megatons of TNT. For comparison, the most powerful nuclear bomb ever detonated, the Tsar Bomba, had a yield of 50 megatons. The impact would cause widespread devastation, likely resulting in massive tsunamis if it were to hit an ocean, or creating a large crater and causing regional or even global climate disruptions if it were to strike land. One of the key factors in determining the long-term trajectory of 1950 Da is the Yarkovsky effect, a force that acts on an asteroid due to the way it absorbs sunlight and re-emits it as heat. This effect can cause small but significant changes in the asteroid's orbit over time, making it difficult to predict its exact position far into the future. The Yarkovsky effect is particularly important for 1950 DA because of its rotation and size, and it is one of the reasons why scientists cannot yet definitively rule out an impact in 2880. 1950 DA is under constant observation by astronomers, and its orbit is regularly updated as new data becomes available. Because of its potential impact threat, it is classified as a potentially hazardous asteroid, PHA, by the Minor Planet Center and is a subject of ongoing study. The asteroid's close approach to Earth in 2032 will provide an opportunity for more detailed observations, which could refine our understanding of its orbit and reduce uncertainties regarding its future path. In the event that further observations confirm a significant risk of impact in 2880, various mitigation strategies have been proposed. Kinetic impact. Sending a spacecraft to collide with the asteroid and alter its trajectory. Gravity tractor. Positioning a spacecraft near the asteroid to use its gravitational pull to gradually change the asteroid's path. Nuclear detonation. Using a nuclear explosion near the asteroid to nudge it off course, though this method is considered a last resort due to its potential to fragment the asteroid. 1950 DA has been the subject of numerous studies and has been featured in discussions about planetary defense. Its unique characteristics, such as its rapid rotation and cohesive forces, have made it a valuable object of study for understanding the behavior of asteroids in general. The potential for an impact, albeit far in the future, serves as a reminder of the importance of monitoring near-Earth objects, NEOs, and developing strategies to protect our planet from future asteroid impacts. In conclusion, asteroid 1950 DA represents one of the more significant potential threats from space, given its size, composition, and the relatively high probability of an impact in the distant future. While the potential collision date is over 850 years away, it serves as a focal point for discussions about planetary defense and the need for ongoing research and monitoring of near-Earth objects. The asteroid's unique physical characteristics also provide valuable insights into the nature of asteroids and the forces that govern their behavior. As of now, there is no immediate danger from 1950 DA, but it remains a key object of interest for astronomers and planetary scientists who seek to ensure that we are prepared for any potential future threats from space.